we are given those two functions, that is one which is quadratic and the other one which is linear. So f of x is the quadratic and h of x is the linear. First thing, you are supposed to determine the equation of the parabola. Alright? Now, in this question here, we don't have the x-intercept. So the best way is to write the turning point form, right? The general equation is y equals ax squared plus q. This is called the turning point form. Okay, it's the general equation. So here, our q, since this point here, where the turning point is the origin, means q is 0. This q here is 0. So we need to calculate a. Now, to calculate a, we are going to use the coordinates of point D. Okay? We're going to use the coordinates of point D. So if dy is 4 and x is 3, so we get 4 equal to 9a. Okay? What this means is that a is going to be 4 over 9. Therefore, the equation there is going to be f of x equal to 4 over 9 x squared. So that's the equation. Okay. So that's the equation. Right, so that's straightforward. Then, but we have got any question there? Any question?
No, sir.
Right, so the next one, we need to calculate the coordinates of C. Coordinates of C refer to the point of intersection. Okay? Now there are 2 points. We have point D and point C. Okay, so let's do the next one. Now, we know that the two graphs intersected 2 points. Based on the graph, we have point D, we know the coordinates. We don't know the coordinates of C. Now, it's very important for you to know that where the two graphs intersect, in this case, we have f of x being equal to h of x, right? Now, so f of x, its equation is 4 over 9 x squared. The equation of the straight line is 2 over 3x plus 2, right? So we need to solve this. It's going to be a quadratic equation, so it will be 4 over 9 x squared minus 2 over 3x equals 0. Then your knowledge of equations is required from term 1. You find the LCD. The LCD is going to be, your LCD here is going to be a 9. So multiply every term by 9. If you do that, you end up getting 4x squared minus 6x minus 18 equal to 0, right? Because if the LCD is a 9, it means I have to multiply this by 3 and that by 3. The denominator here is a 1, I have to multiply this 1 by 9 and the numerator by 9. Okay, so your knowledge of equations is required there. Right, then we need to factorize this now. Now to factorize it, we can go back to the basics. Coefficient of x squared, constant term. If I multiply minus 18 by 4, I'll get minus 72. Right? And then I'm going to need two factors of minus 72 such that they give me negative 6. So those two factors will be minus 12 and positive 6. So this becomes 4x squared minus 12x minus 6. Okay, minus 18 equals 0. And then you get 4x times x minus 3 minus 6x Uh, this was supposed to be a plus. So this becomes, if I take a positive, so this will be positive 6, that will be minus 3 equals 6. Therefore, I'm going to have x minus 3, and so I'm going to have x minus 3 and 4x minus 6 is my factors. So x will be 3, which is this one here at d, right? Or x will be equal to, I think that one must give me a negative, this is the plus. So that will be negative 3 over 2. Okay? So means at C, x is negative 3 over 2, but we also need to know the y value. So we can substitute uh, minus 3 over 2 into the quadratic. So we have minus 3 over 2, that will be equal to 4 over 9 times minus 3 over 2 squared. This will give me 4 over 9 times 9 over 4. Okay? So eventually my answer is going to be a 1. So f of minus 3 over 2 is going to give me a 1. Right? Hence, the coordinates of C are going to be x is, x is minus 3 over 2 and y is 1. Okay, so your knowledge of factorization from term 1 is required when you are dealing with a quadratic function. Okay, so if you forgot how to factorize a trinomial and how to solve quadratic equations, you may have to go back there. Any question?
No, sir.
Okay, and then you need to calculate the length of WO. So the length from here to there. Now we know that in the origin x is 0, but we need to know what is the value of x there. So we use the linear function. Now the linear function is h of x equal to 2 h of x, so this is 6.3 equal to 2 over 3x, 2 over 3x plus 2, right? So since y is 0 there, put y equal to 0, that becomes 2 over 3x plus 2, and this gives me minus 2 over 3x. The denominator is a 1, cross multiply, get minus 6, and then x will be negative 3, right? So it means x is going to be negative 3 here, but the value of y of x here is 0, x here is negative 3, therefore the length of WO is going to be x max minus x minimum, right? So this will give me 0 minus 3, and my final answer is going to be 3 units. Okay. Then the next question says D and T are symmetrical for the line y equal to x. Okay. So point D and point T, they are symmetrical about the line y equal to x. The line y equal to x is this line here. That's the line y equal to x. Okay? Write down the coordinates of t. So, well, that's the point. Okay? So, if you reflect the point about the line y equal to x, okay, what that means is that the x and the y will end up swapping. Okay, so the coordinates of t, most probably they will be somewhere there. So the coordinates of t, that's 6.4. So the x and y will swap. So x becomes 4 and y becomes 3. Okay, because we are reflecting about the line y equal to x. In actual fact, by saying symmetrical about, it's more like it's a reflection about the line y equal to x. So you just interchange the x value and the y value. The x value increases, the y value decreases. Okay? Any question there?
No, sir.
Okay, and then the sketching, you're supposed to get those two graphs. Okay, this one here, it will be your f of x equals minus x squared plus 9.
With touch me ready and geometry, please come to the finance box now. And touch me ready and geometry, and please.
And then the other one will be g of x equal to 3x plus 9. Right? So first thing, you're supposed to determine the values of x such that the two graphs are equal. So you go to the graph, you look at the point of intersection. So for 5.2.1, x is 0 or x is equal to minus 3. Must have got that. We are referring to the points of intersection. Right? So that's straightforward. Then f of x is greater than 0. It means the y values are positive. That's in the first or the second quadrant. So for f of x to be less than 0, sorry, greater than 0, it means that the y values or the graph of f is above the x-axis. And that is only true from this point up to that point. Okay? But since there is a greater than there, we don't include the minus 3 and the positive 3. So our answer will be minus 3 is less than x is less than 3. Okay? Remember, f of x is the quadratic function. So above the x-axis, the y values are positive. That is in the first quadrant and the second quadrant. Okay, and then how does the graph of h of x equal to minus x squared minus 9 compare with the graph of f of x? So for 5.3, remember, we have h of x is given as minus x squared minus 9, and our f of x is given as minus x squared plus 9. Okay? Both of them, they have maximum turning points. But this one here, h of x, it has got a maximum turning point at x equal to minus 9. And this one here is got a turning point at x equal to 9. So compare with the graph of h of x. Okay. Well, what I would say is that h of x is a graph obtained from f of x after a vertical shift. Okay, it will be a vertical of 18 units downwards. So you get h of x if you shift the graph of f of x by 18 units downwards. I'm sure you can see that both of them, they've got this x minus x squared and that minus x squared, which means their shapes are exactly the same. The only difference is that their turning points are not the same. Okay? Or you can say f of x is a graph obtained from h of x after a vertical shift of 18 units upwards. Okay, either way will be correct. Okay, so you can get either of the two graphs after a vertical shift, which is going to depend on which one you shift. It can be upwards by 18 units or downwards by 18 units. Okay, any question there? Then, but we're already.
No, sir.
Right. Then 5.4, give the equation of the reflection of f in the x-axis. Now remember, if we reflect the graph above the x-axis, the y values change, but the x values don't change. So for 5.4, our f of x, is equal to minus x squared plus 9. So if we reflect this graph, we get a new graph. I'm going to call it g of x. Okay? So that new graph, g of x, is going to be equal to minus f of x. Okay? Which means g of x is going to be equal to minus x squared plus 9. Right? This minus here indicates reflection, right? Which causes the change in the sign of the y value. X value is remain the same. So the new equation, which I call g of x, is going to become x squared minus 9. So if you reflect the graph of f, you end up getting x squared minus 9. Remember, when you did the trigonometric graphs, I spoke about reflection rules. So this is a reflection rule based on function notation. Any question there?
No, sir.
Right.